Hello guys, welcome to Oxtrix Laboratories. We are going to build our stereo amplifier based on tda2030 and tda2030A integrated circuit. And this is, as you see, that this is your PCB layout on A4 paper, and properly cutted PCB layout, and which will be printed on this copper board. And okay, and these are the components which are required for building this great project: the diode bridge, the supply capacitors, the other capacitors, and the resistors, and obviously the tda2030 integrated circuits. So these are the things for this project which are required. And now we will start this project. As we see in the notes, that we will start this project by building this by making this PCB board. So as you see that this PCB board is dirty right now, we will clean it first by applying some water on it, and then by rubbing it with this sponge. Okay, so we will start our first process. We will first dip this board in this water, and just apply water on it, slightly wet it, and then we will rub it with this sponge. To remove undesired dirt, any undesired thing from the board. Undesired dust is removed from the board while applying it, and just clean it, because if the board is not properly clean, and it is dirty, then the PCB pattern which will be iron on it will not give good results. So we have to clean it first to develop it perfectly. Okay, so now it's done. Apply water on it again, and apply this water on it, and we see that the board is now okay and ready for. You see here that the board is now clean, and now you are going to iron this pattern on this board. Okay, so we will now do this step. And before doing it, just make sure that there is no water particle on this board. Just clean it with any clean cloth, and then iron it. Iron this PCB layout on this board. Okay, so now I'm going to iron this PCB on this board. Okay, now see that. Now we have this iron, and we have this copper board and this PCB layout, and we will print this PCB layout on this board by ironing on it. And now I will do it. Okay, fixing your PCB layout at appropriate position on the board, and then apply iron on it. Your iron should be hot before applying on this board. And now you will see that the A4 paper containing the PCB layout will be pasted on that copper board. Now you can see here that it is pasted. Now we'll iron on this side. Here you can see that the PCB layout is completely pasted on this copper board. Now keep applying this iron for at least 10 to 15 minutes. Don't apply too much heat on it, just do it. Now after application of 10 to 15 minutes of this electric iron on this board, now rinse this board, dip this board in the half boiled water. Okay, now take this board and this is the board of half boiled water, and now we will rinse this board in this water. Okay, now it's done. You can see your circuit clearly. Okay, and now rub your thumb gently on this paper, very gently, because if you do it roughly, then it may remove the PCB layout from the board which is printed on it. Okay, now do this very gently with your thumb, with your very soft thumbs. This may take some time, but the result will be very good. Washing it to remove the particles, again doing it. You see that the board is done now. Board is okay for etching. Now we will etch this board with the ferric chloride solution. Now this is the pot of water, hot water, and now I will mix this ferric chloride powder in this water solution, and I will shake it to mix it well in this solution. Add more. And now I will dip this board in this copper solution, in this in this ferric chloride solution, like this. I will shake the board until all the copper is removed from the board. It will take at least 5 to 10 minutes or 10 to 15 minutes to do this. So keep shaking it. And now dip this board, PCB board, in this water to clean it. And now you see that the board is washed with the water, and now remove this black colored layout with the help of this sponge. You do this like this. You can see that this required pattern is now on the board after scratching it with the sponge. So you see that your required pattern is here on that board. Now this board is ready for drilling. It's completely done now. Now we will drill all the holes on this board. And now we are going to solder these components on this board, and we have this front layout for the reference, only for the reference. We have this front layout, and also for the reference, while soldering your components, you must have your PC or your laptop in front of you, because this diagram shows you the original diagram which is on the Proteus software, will give you more detailed detail about the components on the surface of that PCB board. Okay, so you must have this layout, this original layout, while doing this thing, while soldering these components on your PCB board. Okay, and one thing more, that this original PCB layout, this original amplifiers Proteus file is also given in the link in the description, so it's all free and you can get it from there. Okay, so we are now going to solder our these components. So the detail of the components, I'll tell you that these are the supply capacitors, which is of 4700 micro farads, and 35 volts each. And we have this diode bridge, we have these required quarter watt resistors, the required ICs, integrated circuits, tda2030, and the capacitors, the polar and the non-polar capacitors. So now we will first, what we will do, we will solder all the resistors, and then we will solder all the capacitors, and then we will solder our supply components, which are the diode bridge. This is diode bridge, and these are the capacitors, and then finally our ICs on this PCB board. So we will do this this thing step by step, so stay with us. Okay guys, and now we have set all the things for the soldering on this board. I have my original PCB layout in front of me on my laptop. This is, you can see here, and by seeing this original PCB layout, I will solder the components. So I'll start from the resistor, and in the diagram I'm seeing that I have here 680 ohms resistor here. So I will connect my first resistor, which is of 680 ohms. The color coding of each resistor is also given in the build on materials. You can see in the description of this video the links, the required links, required for the manufacturing of this great project. So I have fixed this my resistor to the board at the required place, and now I will just solder it like this. Here's the solder wire. Now I will solder it like this. You must have a cutter with you to cut these legs of any component. Okay, I will cut it with this nail cutter. You can use any of the cutter. And now okay, now it's done. Now I have connected the 680 ohm resistor. Now I am seeing in the diagram that and also you can see here that you have connected this 680 ohms resistor. Now I will connect the 22k resistor besides this, and now I will take the 22k resistor. So this is the 22k resistor. The color coding is already given in the build on materials. Okay, and now I will connect my 22k resistor here, just as I soldered my 680 ohms resistor. Now I will solder it. Okay, and it's done. Similarly, I'll cut its legs, and make sure that you do not waste these legs of your components, because they are used for the jumpers in the circuit. Okay, so I'm done with the 680 ohms and 22k resistor. Okay, now I will connect this. I'm seeing here that here is 2.2 ohm resistor. I will take my 2.2 or 1 ohm. You can also use 1 ohm resistance or 2.2 ohm resistance in this case. So I am using here 1 ohm resistance here, so it's not a big deal to use this. So, and again 680 ohms. Now I will do it quickly. This 680 ohms resistor here and 1 ohm resistor here. You can use 2 ohm, 2.2 ohm or 1 ohm, whatever you can use, so it's not a big deal. So I will solder them, these both resistors. So I'm done with it. I will cut them. Now you are done with these 4 resistors, and now I will connect here. I can see that there is 22k resistor, so I will connect this 22k resistor here like this. Okay, similarly I will cut the legs of this resistor, and now I'm done with the 22k resistor, and now we are left with only 3 resistors here. Yes, 3 resistors. Here you can see that we have connected these resistors here. These 3 are these 3, and these 2 are these 2 resistors. So we are now left with 1, 2 and 3 resistors at all. Okay, so now we will connect them. Firstly I will select this again, 22k resistor, you can see here, and you can see clearly in our original PCB diagram, which is given in our website, which is in the description of this video. Okay, Now it's done. 22k resistors, and now I will solder them. Okay, and now we are left with the one resistor. Now we will connect it at that point, which is that point. Solder them. Okay guys, now we are done with the resistors in the circuit. Here are total 1 2 3 4 5 6 7 and 8 resistors. So make sure that you have connected all the resistors here. 1 2 3 4 5 6 7 and 8. So guys, and now we are done with the resistors, and now we will connect all the capacitors here. And for polarity of the capacitors and for placing the capacitors, you must have to concern this PCB. You must have to concern this PCB layout before connecting the capacitors or resistors. So I'm making sure that this diagram is completely free. If you want it, then just mail us, just contact us, so that we are able to. So guys, now I will connect these all the capacitors here, and firstly I will connect the input capacitors, and which are of 0.1 microfarad each. Now I will search for my 0.1 microfarad capacitor here, and we'll solder it here. Okay. So this is the 0.1 microfarad capacitor, and now I will fix it here. And okay, this is the input capacitor, which I have just connected here, and we'll solder it. It's done. Got its legs. Now I will connect another input capacitor, which is 0.1 microfarad. Okay, which is in here. Make sure that the polarity is okay, that you are connecting your capacitor in right polarity. Do not connect the capacitor in reverse polarity. So we have connected these two capacitors, the input capacitors, and now we will connect our 100 microfarad capacitor here. You can see, yes, at this place. Make sure that the polarity is all okay. So I have connected my 100 microfarad capacitor here in right polarity. So it's done. So we have connected this 100 microfarad capacitor, and now I will connect the other 100 microfarad capacitor by saying its right place here, and its right place is at this point here. Let me see it where it is, and it is in here at this point. Yes, at this point. So solder it. So it's done. This is also connected. We have connected this capacitor here, and we are done with these 4 capacitors. Now I will connect the 22 microfarad capacitors here, which is this one. Okay, now I'll connect this capacitor like this. Yes. Another 22 microfarad capacitor, which is connected, which will be connected at this place. It's connected now. And now we will connect we have connected our 22 microfarad capacitors. All the polar capacitors are now connected here, and now we will connect our non-polar capacitors, which are 0.47 microfarad and 104 or 100 picofarad capacitors, which are these ones. Okay, so now we will connect them, and okay, make sure that you are done with your capacitors. Yes, we are done with your capacitors. There are no more such capacitors here. So now firstly, what will I do, that I will connect these 0.47 non-polar capacitors at their places here. This is the capacitor and will be connected here. You can see yes, here. Connect it carefully, not to mix the connections with each other. So it is now connected, and we'll cut it. Now we will connect another 0.47 microfarad capacitor here. I'm taking this another 0.47 microfarad capacitor and going to solder it here at yes, at this place. It's done. Cut its legs. Now we are done with these 0.47 capacitors, and now we have these two capacitors which are 104. You can also use ceramic one or this polyester one, it's up to you. There is no limitation. So we'll connect it here by seeing our PCB layout. Yes, we will connect it here. The other one will be connected at this point, which is below this capacitor, which is here. Solder this last capacitor. And now guys, we are done with all the capacitors and the resistors of the circuit. And now we will connect these supply capacitors, this supply diode bridge, and then these integrated circuits. And now, before doing this, we will now connect our jumper wires here in this diagram. In this upper layer, these black points, these black lines represents the jumper wires. Okay, so these are the jumper wires. Okay, and if you see this software, then you see here that these red lines represents all the jumper connections of your board. Now I'll take these wires, which were the legs of your components, and now we'll make my jumper wires from these wires. Okay, so now I'm going to connect the jumpers while seeing this as a reference. So I'm going to connect my first jumper wire here. Okay, I'm done with this. So I have connected this one as my first jumper. Now I will solder it. Now it's done. I have connected my first jumper wire, and similarly I will connect all these black colored wires on this board as jumper wires. Now we are done with the solder wires. Here we have connected our solder wires as we see in this upper layout of the board. So now we are done with all the capacitors, with all the resistors, with all the non-polar and polar capacitors, and as well as these jumper wires. So now we will connect this diode bridge here, and it will be connected as like this. Now we'll solder it. And now we have connected our diode bridge here on the board, and now we will connect our capacitors, the supply capacitors here. Connect this one. Okay, now it is connected here, and now we will connect this one also here, and this one. Okay, so the capacitors. Now we will solder them. So now we have connected our supply capacitors, all the capacitors, our this diode bridge here, and now only these two tda2030 integrated circuits are left. Now we will now solder them. It's very easy to do this. It's very easy to do this even if you are doing it for the first time. Just take our notes, and there is no obstacle, there is no hindrance for you in building this great project if you have our notes, our PCB diagram, and obviously this video tutorial, which is totally free for you. You can also add us on Skype for further questioning. If you have any confusion in your mind, then you can freely ask anything regarding this circuit. And keep in mind that it's very easy task to do. Just you have some basic knowledge and about electronics and passion to do this great thing. So you are done with one of your tda2030 integrated circuit, and now I will connect the other one. I'll solder the other one just like I soldered this one. You can also give us feedback at our website, which is www.oxtixtechnologies.com. Please visit our site. All the links are also given in the description of this video. So give us feedback and ask us whatever you want about these things. Okay guys, now it's all done. It's almost done. Now we have connected our integrated circuits as well as all the required components. Now I will connect wires here, here, and here. This is the transformers input, whereas this is the audio input, and this is the audio output, from where you will get this its output. So now we will connect the wires here, connect our system to the power supply as well as the input supply to check it whether it's working or not. Before applying it to our transformer, your these tda2030 integrated circuits must have some heat sinking, because if you do not apply a proper heat sinking to them, then it may get burned. So I have these two heat sinks. As these heat sinks are not proper, you must have a bigger sized heat sink to connect with these tda2030A integrated circuits, so that they may have long life. But if you connect them for only testing purpose, then it's okay, but you must have a proper heat sink for them, for both of them. So I will connect them with these heat sinks like this, and so that you may have the proper heat sinking. Connect the other one just like this. So you have connected the PCBs, the heat sinks with your integrated circuit, and now I will connect the wires here, and here to check whole circuit. Yes, now we have connected the wires at the inputs and outputs of this amplifier, and now we will test it, and we'll see that while it's working or not. Here we have applied this strip here, this sleeve here, to join all the wires here. Now we are done with it, and we will apply it here and also here. Okay guys, now we are done with these 3 connections, and this amplifier is ready for the operation. And now we will connect it to the output and to the inputs. So Guys, we have connected this circuit, this amplifier, stereo amplifier circuit, with the transformer, and we have connected this, as this is its output, so we have connected its output to the speakers. So this is the output which is connected to the speakers, and this is the input which is going into the amplifier. And these are the Pioneer speakers. These are the two stereo speakers which we have connected with the circuit. And keep in mind that this speaker or subwoofer is of 100 watts each, so it means that this amplifier is supporting 100 watts plus 100 watts subwoofer. And now I have connected it to my laptop, and now I will play some music, and now I will play it to check it.
Even when you're not around. If there are boundaries, I will try to knock them down. I'm latching on, babe. Now I know what I have found.
You have seen that the amplifier is working perfectly, and it's supporting 100 watts plus 100 watts subwoofer very smoothly. So go to the description of this video to have step-by-step instructions for building this great amplifier project. Thanks for watching the video. Log on to our site www.oxtixtechnologies.com or our blog www.oxtixtechnologies.wordpress.com. Thanks for watching the video. Stay blessed.